Hello class, I hope you're having a wonderful day today. So I would like to complete another practice problem from chapter 6. This is going to be a practice problem that covers uniform circular motion. So let's go ahead and get started. A 2.35 kilogram object is attached to a 2.6 meter thin cable. The object is rotating about an axis in a horizontal circle, making one revolution every 0.96 seconds. So in this problem, let's go ahead and underline some important information that's given to us. So the mass of the object is 2.35 kilograms. The radius, since this object is being rotated in a circle, radius is 2.6 meters. The object is making one revolution every 0.96 seconds. So in this problem, we're required to calculate three things. The first thing in part A is the velocity of the object. And here, let me just write the variable. That's identified by lowercase v. In part B, centripetal acceleration. This is identified by A sub c. And in part C, the tension force in the cable. So what we're going to be doing is calculating the net force applied to the object, which is also known as the centripetal force. So we're going to calculate F net. This is the centripetal force that is applied to the object. This net force is going to cause the object to turn inward towards the center of the circle. And the agent of this force is going to be the tension force in the cable. So I'm going to say force of tension. So force subscript tension, okay? So let's talk about part A, the velocity of the object. So to calculate the velocity of an object in uniform circular motion, you have to know two things. We have to be able to find the displacement vector for the object. So velocity is equal to 2 pi times the radius divided by the time period of the object. Now, not time interval, but time period. And time period in this case is the amount of time for the object to make a full rotation or one complete revolution. And the problem tells us it makes one revolution every 0.96 seconds. And time period is identified by a capital T, not delta T, capital T, okay? So the displacement vector is the full revolution. This is going to be the circumference of the circle that it travels divided by the time period. So let's go ahead and grab our calculator. The radius is 2.6 meters. So let's do 2 times 2.6 times pi. This is going to give us 16.336 meters. We're going to divide this by the time period, 0.96 seconds. And this gives us 17.02 meters per second. So let's take a look at the units there, meters per second. So velocity, 17.02 meters per second. And this is the answer to part A. Now let's talk about part B, the centripetal acceleration. This is going to be A sub c is equal to the velocity squared divided by the radius of the circle. So the velocity, what we're going to do is use our calculated value and plug it up here into our numerator. So our calculated value for velocity is 17.02 meters per second. Divided by the radius, and the radius of our circle is 2.6 meters. Now, according to the order of operations, we need to take care of our exponents first. So that means we need to do 17.02 squared first. Now, not only are we taking the square of the numerical value, we're squaring the unit value as well. So 17.02 squared gives us 289.68. So we squared the numerical value and we're squaring the unit value. So meters per second times meters per second will give us meters squared per second squared. Right here we're dividing by the radius of the circle, 2.6 meters. And this gives us a centripetal acceleration of 111.41. Now let's take a look at the units here. I have meters squared per second squared divided by meter, which algebraically the denominator can be written as meters over 1. And so when we're dividing fractions, it's like multiplying by the inverse of the denominator. So I have meters squared per second squared times the inverse of the denominator, which is 1 over meters. So this is going to cancel one of the meters, leaving us with units of meters per second squared. And this is the answer to part B. Okay, on part C, it wants us to calculate the tension force in the cable, which is the net force applied to the object, which is going to cause the object to continuously turn in to the center of the circle. So, net force is equal to the product of the object's mass and the object's centripetal acceleration. So the mass of the object is 2.35 kilograms. And the centripetal acceleration is 111.41 meters per second squared. So this is going to give us 261.8. So F net 261.8. A kilogram meter per second squared is a newton. And the agent of force is the tension force in the thin metal cable. So I'm going to use a subscript tension. And that is 261.8 newtons. And that is the answer to part C. So I hope this uniform circular motion problem that we just worked through is helping you out in the problems in Chapter 6. If you need any help, please give me a call or send me an email. I hope you have a wonderful day.